Alright, good afternoon everyone, and welcome to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? Alright guys, so let's go ahead and get started. Let's see where we're at. Alright, warm-up number 126, and it reads, graph the circle x squared plus y squared minus 8x minus 2y plus 16 equal to 0. Number 2, compute the circumference of the circle above. Number 3, simplify square root of 9 over 5. And number 4, compute the missing length of the right triangle, and the base is 12, height is 16, and the missing length is the hypotenuse, which is labeled x. Alright, if you need more time, lock your toolbar, and stop the video and go ahead and get started with that. And in the meantime, let's see. I'm going to go ahead and switch here. Alright, so you already have the notes for the process for these. Once again, some of it is review, some of it is refreshing of stuff that we've seen, some of it is part that we're going to need for what we're doing right now. So let's continue. And just go to your notes so you guys can see what we did last session. And it says, for home play, memorize the unit circle. And for last time, I left you only part of it. And today we're going to do another part. Here we go. So our objective for today, I can define the unit circle. Once again, I can define the unit circle. And we are in the same concept. What is the main concept? The unit circle. All right. And we're defining it. So what is the unit circle? You filled out your Frere model. I'm pretty sure you can fill this out again by yourself. Let's see if you can remember, what is the unit circle? What is the definition for that? And I said the definition's within the term. What does that mean? That it's a circle that has what? Yeah, definition, a circle formed using a radius of 1 unit. Example, I gave you guys an example that looks something like this. Here's a radius of 1, and the circle looks something like this. For non-examples, I gave you guys this right here, and of course, whoever's there watching with you, tell them why that one's not a unit circle. Right, because this one has the radius of 3 units, and the unit circle is only 1 unit. So hashtags, I put hashtag circle, hashtag 1 unit radius. All right. And then from there I said, even though we are in the trigonometry functions unit or module, I said we're going to focus on the unit circle. So then from there I gave you guys the unit circle, and then we talked about that if it's a unit circle, that means this is radius 1, and so on and so forth. We know that we came up with this is the x, this is the y. We came up with some points, and there's the work that we did last time. And once again, just to recap, here it goes again. What did we say? So if this is a unit circle, this is the x-axis, this is the y-axis. I'm going to start with a point right here. There it is. And if I was to place a point here, remember when we graph circles, what do we need? We need points that are the same step all the way around. So one step this way, I place a point there. So what is my coordinate there? 1, 0. I place another point up here. What is my coordinate there? 0, 1. I place another point right here. Now that we're on the negative side, what is this? Negative 1, 0. And then I place another point down here, which is 0, negative 1. Okay. But then I said, if I was to place a point about over here, and we said that this is what? 45 degrees. Remember that? We get to the line segment right here. 45-degree angle. And from there, we can form a 45 special triangle right here, and then the work that we did looks something like this. So if I was to connect this from here to here, it's the same from here to here. So what do we need to write these coordinates? We need to know this distance right here and this distance right here. So that means this distance and this distance. And how do we find that? By, once again, labeling that using the Pythagorean theorem. What did we say? That each distance was what? Square root of 2 over 2. So this coordinate then became what? Square root of 2 over 2. But then we said, well, we need to place a point on this side. There it is. But now the x value is going to be on the what side? On the negative side. So instead of being square root of 2 over 2 and square root of 2 over 2, so this is what? Negative square root of 2 over 2, comma, square root of 2 over 2. But then from there we place another point down here. So now since we are in the negative side of the x, negative side of the y, what happens? Then both values are negatives. There they are. And then our last point, which is right here. So then we end up with, it's on the positive of x, negative of y. So this is square root of 2 over 2, comma, negative square root of 2 over 2. All right, so that's where we're at right now. Let me take that away. So we're here. So at this point, we need to add more coordinates to our circle. So last time, the way we got this, or the way we got our special triangle, was looking at a square. And what do we know about the square? A square has all sides that measure the same. What's another word for that? Equilateral. So today's special triangle, I'm going to use now another figure to get that special triangle. So check this out. Where are we at? Okay. There it is. All right, let me zoom in. Okay, so let's see. So this is a special triangle because it's known as an equilateral triangle. So what does that mean? That this side measures the same as this side, measures the same as this side. Now what do we know about triangles? That inside of the triangle it measures 180 degrees. So if these measure the same, that means that this angle measures the same as this angle, measures the same as this angle. Which means 180 divided by 3, that means all of these angles are 60 degrees. Okay. Now is this the triangle that I'm going to use to set my other coordinates? No. I'm going to do something to it just like we did to the square yesterday. Watch. I'm going to cut straight down like this. Let me move it a little bit more. There it is. Oh. Anyways. Okay, I'll just leave it at that, but it's a straight line. Hold on. Anyways, so with that said, so now that we have a straight line down here, so question, if this was x and we cut it straight down the middle, what does this measure right here? Right, it measures half of x. So I'm going to label it here 1/2 of x, because the whole thing is x, but now from here to here is 1/2 of x. From here to here, 1/2 of x, and I'll put that right there. All right. However, do you see a triangle forming right here? Yeah, it's a 60-degree angle. And what do you guys notice here? This is a what? 90-degree angle, which makes this one a what? If this was 60, we cut it in half. That means this is a 30-degree angle. You guys see it? All right. So, with that said, let me get my tool here. And hold on. Okay, that kind of. Alright, so there it is. Alright, so this is that triangle. As close as I'm going to get because my tool is really like giving me a hard time right now. Alright, so with that said, we said this is 60, this is 30, and this is 90. Okay, so do we know what this side measures? Yeah, that side measures x. Do we know what this side measures? Yeah, that side measures 1/2 x. And do we know what this side measures? No, we don't. So that means we need to figure out this side. So what do we know? If we were to use a squared plus b squared equals c squared. So let's see, what is a? I'm going to use this one. I'm going to use 1/2 x squared. Plus, what is b? We don't know, so I leave it as b squared equals, what is c? X squared. Alright, let me make some space. There it is. Alright, so 1/2 squared. What is 1/2 squared? 1/4. What is x squared? X squared plus b squared equals x squared. Alright, so we need to figure out what b is. So that means I need to get rid of this one, so I subtract. Let's see, subtract. Let's see, I'm going to use. Yeah, I'm going to use red. Minus 1/4 x squared minus 1/4 x squared. So we're left with b squared equals, what is 1 minus 1/4? So imagine you have $1, take away 1/4. What does that leave us with? Right, 3/4 x squared. Okay, so what's our last step? To solve for b, we take the square root. This cancels this. We're left with b equals. So let's see. The obvious one. What does the square root do to this squared? It cancels it. So we're left with x. Okay. Square root of 3. And what is square root of 4? 2. That is correct. Therefore, this side right here measures x square root of 3 over 2. Bam, let's go. However, let's see. What do we know about this side? This is x. So let's use this to go back to our circle. Let's see. Once again, if you need to pause it, pause it. And let me move this way. Okay. Alright, so let's see. Looking at this right here is our hypotenuse from here to here. Alright, what does that mean? That if I was to draw another line this way, and I'm going to make it what? How many degrees now? 60 degrees. So let's see. Let me get my protractor in here. Okay, there it is. So let's see. And if I was to draw a 60-degree angle, 60 degrees is about right there. So I'm going to label that one, and I'm going to label it in red. 10, 20, 30, 40, 50, 60 is about right there. Right there. Okay. So if I was to sketch a line that way, I'm going to do it in red so you guys can see it. There it is. Okay, so that red line is basically representing this part. Okay, do you guys see it? Yeah. Okay. However, what does this measure? What do we know it measures from the center to the circumference? What does this measure? That is right. That measures one unit. So if x is 1, that means this is 1, right? So how about this part? 1/2 times x, which is what? 1. Okay, and gives us 1/2. That is correct. How about this one? 1 times square root of 3 over 2, which is square root of 3 over 2. All right, so what did we learn? That this height from here to here, from here to here, this height right here is what? 3 over 2. So my y value at that point, let me make a, hold on, sorry. My y value, let me get this out of the way, sorry. At this point is square root 3 over 2. But I need this value of x. What is that value of x? It's right there, 1/2. So I'm going to label that 1/2. Do you guys see it? From here to here is 1/2. So that means from here to here is 1/2. And then this part right here is what? That part is square root 3 over 2. Bam, let's go. All right, copy that. And let's add some more points. All right. You're saying, oh, I think I know what you're going to do, Mr. Q. I know. So we got this one here, but just like this one, we reflected it over here. So if we reflect this over here, that means it's going to be somewhere right there. All right. Question, what is the coordinate of this point right here? What is x? Yeah, this one was what? 1/2. So that means this one is negative 1/2. And the height, which is the y value, it's still square root of 3 over 2. Okay. Let's reflect it down here. There it is. So it's on the negative of the x and on the negative of the y, so that means this is going to be negative 1/2 and negative square root of 3 over 2. Bam! You're like, Mr. Q, this is a piece of cake. I know. And the last point, I'm going to reflect it about right there. And that one is positive 1/2 and negative square root 3 over 2. Piece of cake? Yep. But we're not done. Alright, now check this out. I want to take this away for right now. I just used it so you guys can see the triangle in there. Let me put this away. Alright, there it is. Now, we said that to get to this point, this was what? 60 degrees, right? 60 degrees. Alright, but what if I did this? What if I did this? I went 10, 20, 30, 30 degrees. Do you guys see it? 30 degrees. Okay. Let me get this out of the way so you guys can see it. Alright, and once again, let me sketch. This is what? 1. Alright, hopefully some of you see it already. Okay. Here's 1. But what is this degree now? 30. So what is this degree now if I was to sketch a line? straight down like this. This is 90. All right, here's the 90. Here's the 30, which is over here. So wait a minute, 90, 90 and 30. So what's the distance from here to here? 90 and 30 is, oh yeah. Yeah, so the x value here, from here to here, we know what it is because it's this one right here. Because this is 30 degrees. So that means this is square root 3 over 2. If that's true, and this is the 60 degree, check this out. This is 60 degree, which is this one right here with this one. So what is this length right here? 1/2. That means this is 1/2. You're like, oh, it's just backwards. Yeah, it's this one backwards on that side. Bam, let's go. So, and with that said, guess what? Now we're going to reflect those points. We're going to reflect this one over here. All right, tell your neighbor what that coordinate is. Yeah, now it's on the negative side, so negative square root of 3 over 2 and 1/2. Okay, let me reflect it down over here. Alright, now we're on the negative side of both values, so it's negative square root of 3 over 2 and negative 1/2. And if I reflect it over here, that one is positive square root of 3 over 2 and negative 1/2. Look how pretty that it looks. Yeah, let's go. Copy that. All right. So, let's see where we're at. Let me zoom out. All right, students, unit circle, students. And basically those are the coordinates that you need to memorize. I know. Last night you did, or the other day you did just the blue ones. Now you have to do all the coordinates all the way around. From this 30 degree one right there to the 45 degree to the 60 degree. If you want to change the colors, you can change the colors. I just use that so it can make contrast and you can see what each piece, where it came from. And those were the special right triangles that we used in order for us to find those coordinates. Now, are we done? No, there's one more thing that they're going to ask you to find, which is the radians. And radians basically comes from the word radius. That is correct. So basically, all they're asking you to do is to label all the way around with radius each of those points and label it according to radians. And what is that, Mr. Q? So basically they divide the circle into sections, and those sections are called radians because they're based on the circumference. You're like, what? Yeah, so watch. Let me do this. Let me make some space over here. Hold on. All right. So check this out. So if I was to ask you to find me the circumference of this circle, you're like, oh, Mr. Q. I know, I'm telling you, everything we do in class has a purpose. So check this out. If I was to find the circumference, how do we find the circumference of a circle? 2 times pi times the radius, right? Okay. But what do we know right now that the radius is in the unit circle? 1. So if we substitute 1 in here, doesn't it, kind of like disappear, because 1 times 2 pi is what? 2 pi. So this ends up being circumference equals 2 pi times 1, which is circumference equals 2 pi. Okay, what does that mean, Mr. Q? Okay, that the circumference is 2 times pi. So what is the circumference? The circumference is all the way around the circle, all the way around. What is it? All the way around. How many degrees? 360 degrees all the way around. So if it's all the way around, if I go start here and I go counterclockwise and I stop here, that's 1 circumference, which means what would be my label here to let people know according to degrees, or now according to radians, that the circumference is. The circumference is 2 pi. So that means this right here is what we know as 2 pi once we go all the way around. Bam. So question, what does it mean, check this out, if from here to here, isn't that half of the circle? Yes. So if 2 pi is all the way around, what would I label up to right here, which is only half the way around? Once again, all the way around is what? 2 pi. So what is it up to right there? Right? Pi. Now guys, this is very important because you're going to need this for now that you're going into pre-calculus, trigonometry, and calculus. You need to know your radians, and that's why I kind of like tic-tac-toed the unit circle so you guys can see where it comes from, and it's fairly simple. And then from there you're going to work your way around with the radians, labeling everything with radians, and then from there you're going to do what? You're going to go and use all that information to come out with your sine, cosine, and tangent, and then all the other inverses, right? So up to right there we're good, right? So now check this out. So we know that pi is from here to here, and that's how many degrees? 180 degrees. Okay, 180 degrees. So from here to here is pi. Yes. So let me do that. Hold on. Let me look at my perfect circle. Alright, hold on. So there's half of my circle. So half of my circle, we said that from here to here this is pi. Do you guys see it? There's my half circle. Okay. So question, what would this point be if this piece is pi and I divide this like this? What would I label this part? Yeah, if this from here to here is pi, that means this is pi divided by 2, because we just divided that piece, which is pi, divided by 2. So I would label this one right here pi over 2. Okay, so let's see. So 0, half a pi, 1 pi. So question, if I was to add another piece right here, what would I label this part? So half a pi, full pi, what would I label it up to right here? Yeah, 3/4 pi. Oh, my bad. It's 2, half a pi, pi, and then we add one more half. So let's see, pi plus 1/2 pi. So that is, this is 2/2, so this is 3/2 pi, sorry. 3/2 pi. There it is. Okay. How are we doing? 1/2 pi, another half of pi is pi, another half of pi is 3/2 pi, and another half is how many? 2 pi's. All right, there it is. Okay. So, check this out, let's continue. So, that's that. Let me get this out of the way. If I was to extend this to another session, I would have continued with the next session to make sure that we labeled everything in our radiances with our coordinates and all that correctly. But for tonight, you're just going to memorize the coordinates, see if you can label the radians by yourself. And I believe that's going to be our last session, guys, for this school year. Okay. Over the summer, I'm going to continue adding more lessons to the Algebra 2 piece, just to kind of like complete the entire course, so I can have that available for next year. So, but in regards to anything that's going in the grade is up to right here. Okay. Now, before I log off, I just want to once again say, the circumstances are not the best that we hope for in regards to being face-to-face in class. I know we would have wanted to finish strong and together, but we do what we can with what we have. All right, and like I've always told you guys, take change and take it as a challenge to become something better, and take it as a challenge to grow into someone better. All right. And also, I want to let you guys know that that it was a great year. It was an awesome year, and it was great to see you guys and have you guys in class. All right. So keep up the good work. Don't forget about what you learned. Don't forget about what you learned outside of the academics. What your family, what your friends, what your teachers. Some of us that stopped our lesson also to talk to you guys in regards to experiences and such. Take that and take it to continue developing into someone better. Okay. Also, I want to send a shout out to my seniors that this is their last year at Imperial as students at Imperial High. So let's see, from the top of the list I got Isabella, Sammy, Morgan, Roberto, Aldo, Aaron, my TA Marcos, behave. I got Alexia, also my other TA Joseph, bam. Jade, hi Jade. Cindy, and Patrick. All right. So those are my seniors. This is your last year. This is your year, and remember, just continue moving forward and take this as a stride, and take it as like I said, a challenge to continue developing into someone better. All right. And I'm gonna leave you with this. I usually give this speech till the end of the school year, but I'm gonna give you this right now, and I tell all my students, and since you guys are, the first thing is that be a better you. Be a better you every day. So what does that mean? So whatever it is you want to be, just be a better you every day that you wake up, so that you can develop into improving yourself. If you already know who you are, or whatever it is you want to be the best you. Improve and continue moving. Okay. Second, always do the right thing, because there's going to come situations, or people are going to put you in situations that you're going to have the opportunity to do something that's maybe not right. Remember, always do the right thing. Okay. And what does that mean, Mr. Q? Whatever that means. And sometimes it's going to cost you, like it costs some of us, friendships. Maybe some family are going to stop talking to you, and only because you didn't want to go with the flow. But hey, you got to do what's right. Always do the right thing. Okay, and lastly, make this world a better place every day. What does that mean? Well, from the time you wake up till the time you go to sleep, uh, be someone that is making this a better place, because that pretty much is going to be our legacy, guys. We're going to be here for a moment, and then all of a sudden, our legacy is going to be what we helped to do, or to have this world become a better place. Whether it's, especially in tough circumstances, there's going to be people that are going to need a hand, or some help. Be that person that helps. Leave all the negativity, leave all the friction, all the bit pickering and arguing with people. Leave that all aside. There's already enough negativity and stuff going on around us to bring that in again. Just make this place a better place on a daily basis. You be the one that makes that change. All right, guys. Well, with that, before we log off, I'm gonna be sending everybody an email, or if you want to send me an email, and I'm putting together my playlist, bam, so I can get you guys that before you go. I know it would have been nice to get something physical, but at least you're taking something electronic. All right, guys, and like I tell you guys all the time, if you're not moving forward, then you're already behind. All right, guys. Well, keep up the good work. Love you guys. Hope to see you guys soon. Peace.